All right, last topic is going to be the distance from a point to a plane. And define the distance of a point to a plane. What we're going to do is we're going to find, whatever our point is, and then we're going to plug that point into, the plane that we're dealing with. And then what we will finish up doing is we're going to divide it by the magnitude of that point, of that plane at that point, or the vector of that plane. And so the normal vector. And so here we have an example, finding the distance between the given parallel planes. So we have two planes, and what we want to do is we want to pick a point on one of those planes. And so I'm going to pick a point on the first plane. And so the first plane is 6z equals 4y minus 2x. Now we can always find a point given a plane, and all we need to do is set two variables equal to 0, because it's going to eventually cross an axis. And so what we're doing is we're finding out, okay, where does this plane cross the z-axis when x equals and y equals 0. And so we do is we plug that into this formula, because this is the plane that we're dealing with. 6z equals 4y minus 2x. So we're going to plug in 0 for x and y. When we do that, we're going to get a point 0, 0, 0. All right, and now that's the point that we have. And now what we want to do is we want to go ahead and find the distance, and we're going to use the plane that we did not use to find the point. So we're going to find the distance using this plane now. All right, and now to set this up, we're going to take the magnitude of our second plane, but I'm going to go ahead and rewrite that second plane to be, change the colors. So you see it's going to be 0 is equal to 1 minus 3x plus 6y minus 9z. All right. And what I'm going to do is I'm going to go ahead and plug my point into my point p sub 1 into my equation for the plane, and then I'll take the magnitude of that. So we're going to have 1 minus 3 times 0 plus 6 times 0 minus 9 times 0. And we're going to divide by our vector of that plane. And so our vector of that plane is, again, all of our coefficients. So it's going to be the square root of negative 3 squared plus 6 squared plus negative 9 squared. All right. When we plug into the top, we're going to get, a magnitude of 1. And in the denominator, we're going to go ahead and square root. So we have 9 squared plus 36 plus 81. And then we're going to have the magnitude of 1 is just 1. And we're going to have that over the square root of 126. And that simplifies to 1 over 3 square roots of 14. And so there's our distance. So distance is not bad. It's just requiring to make sure that if we're given, two planes, make one plane find our point, and the other plane is the plane that we're going to use to do the distance formula from that point.